So I guess I can start. First of all, thank you all for coming. This actually means a lot to me. Not so long ago, I was just studying in Técnico, the building right next to it. I can see some familiar faces. I hope you all enjoy as much as I certainly will. So I'm going to talk a bit about monitoring the CERN data center and the WLCG grid. So, well, you might have now understood by Ricardo talk a bit about this. Some numbers might not actually fit his numbers, so that's something I should have set with him, but his numbers are probably more accurate than mine. So today I'm going to talk about, well, this is the plan for today. Start with some introduction about our infrastructure at the monitoring team, some dashboards / use cases, so actually what our users doing with our infrastructure and service, and then wrap it up in a quick summary. So a bit about myself. I'm a software engineering, even though what I do daily can be a lot of things. I can start doing something about DevOps in the morning, end up deploying some patch to something that we are doing with some open source tool we are actually using. I've joined CERN not so long ago, actually not as long as Ricardo for sure. However, I think this can be a good thing. I mean, different perspective. And what I could tell I do, it's basically, yeah, I design and operate complex pipelines for a living. I hope you in the end will understand where my background more in data engineering than in DevOps have actually merged, and how these things are starting to merge these days. This actually is the first photo I sent my girlfriend when I joined CERN. I was a bit like, oh, let's see how it goes. So, yeah, first off, how did I end up in monitoring? It's not like one day you wake up and decide that you want to do monitoring. It started basically when I was building micro recommender systems for my thesis, and I noticed that I was storing stuff in the SCV file, and probably I could be doing better. And this took me to data engineering, which eventually I was now operating an analytics infrastructure, which was a cluster based on Hadoop and so on. And this took me like, how could I automate all these tasks that I'm doing and operating this infrastructure? And by this time, I actually got the chance to work at CERN, and it was actually a role that would fit my questions. So I started and joined like 1 year ago. So yeah, basically this was me doing my master thesis. I was the left shoe, pretty pure as an angel, but eventually I'm getting more dirtier. This is me getting monitoring data. It can be like a bit dirty, but still a lot of fun, but a lot of data integration that happens at my job. So Ricardo also already gave a pretty nice explanation of what CERN does. I'm just now going to explain some of our users. So as a monitoring team, we deploy a monitoring service, and for some users. I'm part of the IT department. We are over 300 people. We have this mission, let's call it, enable the laboratory to fulfill its mission. This can be a lot of things, obviously, but mostly make physics work easier by providing them software. Some projects we have go from the data center that Ricardo explained. This one is the big one. We have IT services, and this can be from storage, like Ceph, and to the computing side, to network, and so on. We also have the infrastructure services like hotels and bikes. All this kind of stuff needs to have software that is built in-house. So we actually provide an infrastructure for all these users and all the software engineerings that are creating these kind of services. I don't think I need to introduce this much more. Ricardo gave a pretty nice explanation. We monitor every single machine that's on this data center. These include also the virtual machines that run on the private OpenStack cloud. We also monitor the WLTG computing grid. It's a huge project. So more than 10,000 physicists are using it. There are like a bunch of sites that make this run. This is split by tiers. So different tiers can actually have different SLAs and different data retention policies and so on. But we have to monitor not only, we don't monitor actually the machines themselves, because there are a lot and they are in each site. But we monitor things like the transfers between places. So like in UK, there might be like a site that is providing some kind of data, and some Bulgarian guy wants to have this data on his PC. So we monitor the transfers that go between these two places. We also monitor the jobs that physicists run on this thing. So actually we can understand how many jobs are getting cancelled or how many jobs are running. And like Ricardo said, we can actually see whenever there is like some sort of conference that physicists want to engage on their analytics, we can see a huge bump. And that's one of the issues that I am actually going to talk. So in the end, our mission is to provide monitoring as a service, mainly for the CERN data center, to the IT services, and to the WLCG collaboration. This can be either dashboards, alarms, search, or archive. To get to this, we collect, transport, store, and process either metrics or logs. And this can be for either an application or for infrastructure. And the application is a pretty good point because we also monitor if the user wants applications. So moving to the infrastructure, some of the challenges we have, and I'm going to first show you some challenges so you can understand some of our choices in the infrastructure later on. Yes, so only from the CERN data center we get like, you can see here the numbers are pretty explicit. So the data center metrics are the biggest part, and then we have the data center logs and the WLCG metrics. This can go pretty heavy, so 3 terabytes per day. This is already compressed, and we have to process this in our pipeline. Other challenges can be variety and reliability. We have a lot of producers, so each service manager can send their data in some kind of format, and we have actually to do the data integration between these producers. For instance, we can have syslog that are being sent in one way, and in another way we have metrics that we can get for the CPU of the machines in another producer. Because we have so many producers, sometimes they have different data rates, and one time one of these producers can like spike it up, and we end up with a huge spike of data. So our infrastructure must be also able to, well, deal with this. For instance, there was this topic here. Is it working when I turn on my face? Okay. So when this topic basically spiked in this day for no reason, it seems. And well, it was pretty low on the normal days at blue, and suddenly it spiked. Well, so the key concepts, our infrastructure or architecture, let's call it for now, are 5. Keep it modular, so we can actually not be dependent of any of these things and can upgrade one or take it out another. Built on open source tools. This is basically a CERN framework, which we always try to go towards the open source way. Should be easy to do data integration. So we have so many data sources that we want actually to make them faster to get in our platform. So if we have a data integration that's poorly made, it will be hard for us to actually get the data that the users want easily and fast. We have decoupled producers and consumers. So the producer doesn't actually have anything to do with the consumer. So, and if one goes down, the other might keep up. This helps us also scale different producers. So the syslogs producer might have an hard day one day, so we don't have to change the other producers and only scale this one. We have built in streaming processing, pretty handy these days. We have a lot of things that we have to enrich data. So for a user, having his having some kind of information might not be enough. So he wants actually to get it enriched by some other API or some other source of data that we might already have in our platform, and you can do it with the stream processing, which helps us a lot. This was one of the big deals of moving to Kafka. We also support multiple backends, different users, different needs. Some users want to have metrics stored, some users want to have logs stored, so we try to have some kind of backends that can be used and can actually fulfill the user needs. So in the end, we have this kind of picture. I guess it's a pretty common picture these days for any pipeline. We have in one side the data producers, in the other side the data sources. They can be decoupled. In the between, we have Kafka as a glue in everything here. We deploy Kafka ourselves, even though it could be, we have a team just for that. We could have been using their service. Decisions were made back then. But in the sources, one important thing, we have multiple types of data that we can actually ingest. It can be either by HTTP. We have HTTP endpoints that the user can send their data in, so they don't have to be actually tackled on deploying things on the machines. But most of the things that we monitor at CERN from the CERN data center are done via collectd. We deploy in every single one of these machines collectd. It provides us either OS metrics or hardware metrics, and anything that the user actually can also build on top of collectd, we encourage it. There is a bunch of collectd plugins that are built in-house and that our users actually want to build more on top of it, and they can actually be reused again. So collectd and its plugin functionality, it's been a great feature for us. And yes, the backends in the end. So we have HDFS, for instance, when we want to archive things. Elasticsearch for logs, obviously, and then InfluxDB as our main time series database. We have been exploring other kind of time series databases, but for now, because we are using a service in-house of other team, the DB on-demand team, we have been using InfluxDB. And then the Spark here, to make the so-called enrichment that I mentioned before. This thing is actually running on the top of one of those Mesos clusters that Ricardo mentioned. So there were two guys running Mesos, one of them was us. We want actually to move this into Kubernetes probably to make our life much easier because, well, it's just there, this thing. Yes, and I mentioned Swan. It's the way that actually physicists love to get access to our data. So they love Python notebooks, and Swan is like a Jupyter, let's call it. And yes, so after Ricardo actually been in KubeCon, our colleague Luca Magnoni was very interested on the topic and started taking a look at some recaps. And he noticed that, well, this gentleman called Clay Smith, when he was writing his recap, he noticed that there was something that was being sold now called observability pipeline. And it seems that ourselves did one, even though we didn't know that we were building this observability pipeline. What we did is basically a bunch of startups in KubeCon were selling this idea that you just put data inside some pipeline, it's a black box for the user, and then it gets out for whatever use that the user needs. And this felt very good back then. It was like validating our work. It was pretty cool that we are building things that are now being marketed as fancy, but these decisions were three years ago, so pretty nice. So a bit about our dashboards and use cases. Whenever a user starts to using whenever a user actually deploys a machine and has his own virtual machine, he can actually have this dashboard. This one has the information that the user needs for his own machine, from CPU, network, memory. Well, you see. This dashboard is common for most of the users, so they can actually filter and check other things out. But important things are, this thing is running on all machines that we have in the CERN data center for virtual machines. And they can collect either OS or hardware metrics. And because they're running collectd, they can also get local alarms. So collectd provides local alarms. They are very useful because they have something called an actuator, which, like for instance, we are checking if a machine is down. We have an alarm for that, and we can set an actuator to just okay, if the alarm is triggered, just make the machine up again. So we can actually merge some functionality here. And then we have service-specific monitoring. So if a user wants something more specific, like I mentioned before, you can either create this collective plugin or actually use our Monitor Metrics endpoint and send to us any data, as long as it's in our format. And this data will just get in our pipeline, and it will get all the features that we provide. It will be enriched if he needs. You will get straight access to our dashboards, to our HDFS. So the user doesn't even need to actually deploy any machine inside CERN. They can just, let's say that you at home want to monitor your plant. You can do it. You just send data to us, to our endpoint. We accept it, whitelist it, and then you get your plant monitored. Yes, and that's something we do for the service availability, for instance. So the users or the service managers send to us the data that they want to declare as their service availability, and then we build this dashboard, for instance. This one is a complete historical view of the service availability on the IT CERN department. These are some of the services. Well, this one was not so good that day. Well, those days, I guess. We have some integration also with the outages. So we have this platform called ServiceNow, and ServiceNow is like a ticketing system, which has been pretty useful. Whenever there is an issue with some kind of infrastructure, the user opens an SSB, let's say, an SSB outage. And this says that, okay, we had this problem, this ticket is open, please, if anyone is having issues with our infrastructure, please take a look at this ticket, as this SSB. And we found a way to integrate this with this dashboard, and it's been pretty useful because sometimes you can correlate both things. And it's just one example of how we can actually use different data sources to correlate them, and why the integration sometimes is a bit harder because we don't know actually what we want. Eventually, we just get it, and it's nice. Yes, so I told you we monitor the WLCG experiments. We monitor the transfers. This dashboard is an example of us monitoring the transfers between different countries. We could see here that there is some kind of issue between Netherlands and Spain. There is only on the efficiency of 73%. This dashboard itself has some nice feature, which are human beings called shifters, who keep tight control on this. So they actually are people that have keep tight control on this, and if something here pops as dangerous, they actually warn someone about this. Even though this could be alarmed, but this one is pretty serious one, and they actually prefer to have someone called shifters for this. Yes, another thing is the job monitoring. This one actually is done by more at experiment level. This one is for the Atlas. So these are the jobs that are running on the Atlas data. They are classified by state, source, or resource. As you can think, it's pretty useful to understand the number of jobs that are running, if there are any issue. This is something that many physicists want to keep a track on. There are a lot of more things that we can do with WLCG. There is also, because we define it as a WLCG, but also the experiments monitoring, because we can monitor an experiment in particular, and that would be like a new organization in Grafana, and we could even enrich it with more data. We also keep track on the site availability, for instance. If there is some part of the decree that is not okay, we actually have that information because we also accept it in our pipeline. And the final, let's say, use case should be alarming. There is a lot of work done here. This is our, actually, in my team's dashboard. We have a big interest in keeping Flume under our radar, Kafka as well, and Kafka Connect. We are now moving towards Kafka instead of Flume, but we try to keep these things in tight control. But these ones are running on Grafana alerts. They are not running on the collective alerts. There are different alert engines. We have this possibility of setting alarms at different levels. Again, alarming is as the monitoring. We have a set of alarms that come straight off the box if the user starts using our platform. And we also provide some external source, like the alarm source. Again, an HTTP endpoint that the user can just send their own alarms to us, and it gets through our pipeline. It's cool because the user might not be using Grafana or CollectD, but still likes to wants to keep their alarms, to get a ticketing service, to get like a mailing, to get to our Slack, which is Mattermost, so they can get this every single thing of this just by sending to our HTTP endpoint. These are all integrated with the ticketing service system ServiceNow. Yes, service alarms. So the user can actually, even though that we have a bunch of local alarms, base alarms, the user can also specify his own alarms. We have a huge repo with alarms that are being created by other teams. If the user can use other alarms, they can actually build on top of them. That's great. So most of these, like NGINX wrong, it's just using another one that it's called service wrong. So there is this nice functionality that we can build on top of each other. And it's as simple as use Puppet. Like Ricardo mentioned, we have a very huge Puppet base. In this case, they just need to call this module, any of this module, and they have the alarm specified. There is, well, obviously some tuning that should be done, like setting the number of hits that the alarm must do before triggering the alarm, but these all can, right now it's as simple. Nobody actually needs to understand about deploying a service, CollectD plugin, which are written in Python. They can just reuse any other one, but by just calling them on Puppet. And this works for everything else in our team. So other plugins that we create, they can also be called in Puppet. So in the summary, the team, we are 6 guys, 2 Portuguese, 2 Spaniards, 1 Italian, 1 Bulgarian. Even though we are kind of op-ish, we work as any dev team. We managed to do it. 2-week sprints, 15-minute dailies, 1 member in Rota. Rota is our on-call guy. We swap it every week. This member also has the burden of answer to customer service tickets. So we have obviously many users asking, why is this not working, or how can I use this feature, or whatever. What can I do to improve this? We have this 1 member just for this. Teams reach us by Slack or Mattermost, mail, and the ServiceNow ticket or Snow ticket, which is our ticketing system. So if a user actually wants to have his data on our platform, usually the normal procedure should be like open a ticket to us, say which kind of data they are using, what is the name of the producer we should white label for them, and as simple as this, they get their data inside our platform. So that's the easy data integration that we were looking for. And yes, GitOps, like Ricardo mentioned, we maintain our code in Git. There is a huge base of the code that is in Puppet. So even though a plugin can be written in Python or any other language, eventually it will have a Puppet module, a Puppet class that we will call later and run it on our infrastructure. For other examples might be the Spark jobs that we run whenever we need to enrich some data. Also, one repo per Spark job. And we integrate a lot with GitLab CI. We have been using GitLab. It works as a charm. I mean, we can build the package, we can deploy the package, we can do a lot of things there. Yes. So in the end, we were able to create a stable production infrastructure, which is not easy in this case because the challenges were hard. Integrate with many different monitoring use cases and scale. Ricardo might have mentioned that this is always growing. It's expected to keep growing. So eventually, the monitoring use case will just grow as the data center grows. It's plain simple. And by numbers, 90 active users, more than 1,000 dashboards, and this is like 1 million queries per day to our dashboards. This is Grafana getting like huge heavy load on them. This can be an issue sometimes because even though it's Grafana, we have InfluxDB below, and InfluxDB sometimes can have some struggle, so we have actually to do some organization between databases and see what can be split so that sometimes queries just don't kill the dashboard. And yes, we have 30 Grafana organizations, all tapping on our managed data sources. So an organization can be like a team or a bunch of colleagues that are working on some kind of project. And one thing is common to everybody that is using Grafana in our infrastructure is our managed data sources. So they can be reused again. And okay, I think that's all. Thank you.
What sort of files are produced, stored, used, studied? I think I understand that the system is taking photos very quickly. So what is the extension of the files that are recorded?
Okay, I see. Yes, it's a fair question. We use mostly Kafka here. So we are using Kafka topics, basically. And we don't actually have files turning around. So sometimes we receive them as JSON in our endpoint, but eventually they will just go to Kafka, and I cannot be actually quite sure what is the section that Kafka is using. But what we work is with events in the end. So even though we might receive a huge JSON file with a bunch of metrics, we try to make each one of these metrics as an event, and it just goes into Kafka. As long as it's in Kafka, then it's just a matter of optimizing Kafka, and it will eventually end up in one of the backends. And in the backends, well, it can be anything from logs to the Elasticsearch to the time series, which use their own kind of file storage. Was this? The size of the files that we accept sometimes can be an issue. That's a good point also, because we accept any kind of file that the user actually needs. So because we have so many kind of users, we cannot actually just say to physicists that, okay, just make this file shorter, please, or something like that. Sometimes they are working in the batch way, the batch thinking way, which doesn't fit much of our infrastructure, but we still have to accept it. So we actually end up sometimes with our producers quite heavily attacked because someone just sent us a huge file of a JSON file, which is, yeah, it's an issue. But we try to make them as short as possible.
How much of the historical data do you keep? So, I think you cannot keep all, right?
Yeah. That's a fair question as well. It depends on the use case. So we set with the service managers what kind of retention they can use. We obviously always try to shorten this period as much as we can, and it also depends on the backend. So if it's Elasticsearch, sure, they can last like, we have things for 5 years or something like that. Even in Flux, we have data for 5 years. The thing is just we create several different interfaces, let's call it, and we try the users to use like the shorter ones more often, so that they don't actually end up querying like, show me every single job that was running on this thing for 5 years. So yeah, but we keep it, we try to limit it, and eventually we have different data retention policies.
So being surrounded by scientists, don't they challenge the accuracy of monitoring often?
They challenge everything. It's not only that. Yeah, sure. We don't have much. We don't have that issue that much because it's an open collaboration environment where we work on. So most of the times, scientists know that we are doing our job as we know they are doing their job. So that's eventually we come up with an agreement. Sometimes we have tickets like in the morning that are open like, my data is not showing, it's wrong, and that's it. Eventually you have to explain, okay, you are using this tool not in the best way and so on. And in the end, we at the monitoring team, we don't actually do at the monitoring by itself. We are more like monitoring champions. We work with the teams, we work close to them, and they actually say, okay, we have this data, what can we end up monitoring? And in the end, we get an agreement. So, yeah.
Thank you.
So for the long-term data that you keep for, you use Kafka or you just dump everything in Flux?
We just dump everything. Well, we have some retention policy on Kafka, not the biggest one. It should be just enough for us to, if there is any kind of issue, we just have some time to get everything together again. Yeah, we usually the normal flow should be dump everything on Kafka, do whatever you need, and then get everything on the back end. The data will still be there in Kafka if you need to rerun the job or something else, or if there was some inconsistency on the back end. But eventually, it's not like the longest one in our project, for sure.
But this is a decision because you have Influx for that, or it works better in Influx, or because you can use Kafka for long-term persistence. I would like to understand the decision why not using Kafka and using Influx.
Yeah, I probably don't want to tell something to you because these were decisions that were taken like before I was even in. But the feeling is that our Influx DBs, because they are managed by another team, and we have some kind of quote and an agreement with them. And the agreement was, okay, we'll try to fill this space as much as we can. We'll try to use the service as much as we can. And because the Kafka service is managed by us, we don't feel actually very confident in having like the whole data in Kafka that much. We want to use it as like a pipeline format. We just don't want to have a data lake in there. We just want to use it, transform it, and then do it. Yeah. Also because it's not the largest cluster that we have. And you saw that we have a huge stack, so sometimes it's not very hard. It's not very easy to every single thing on the fly there, and we try to minimize the things we have to manage.
How do you create and maintain your dashboards? Do you use any framework, or do you do it manually?
Yeah, I get your question, because these are Grafana dashboards. They can be easily stored. Right now, we don't do much on that picture. They are there. The Grafana its own as the versioning feature that you might have used it, and as far as I know, they are just there. That could be easily done, and then store them on Git or something like that. But we are not actually much. We don't have much. We are not worrying much about it. Thank you.